Okay, next, I think we are ready to go to the implementation. We have seen different types of terms used in the tree implementation as well as its relationships. So in the implementation, we can apply in two types. Either we implement it as array or linked list, which we will dynamically create our nodes using our pointer. So for the array implementation in the array format, it works only for the perfect binary tree only. Okay, so there are very limitation, right? So normally this is not recommended. Normally we use this one. Okay. Just how we implement it, we define our child, which is based, for example, at index I here. What is its left child and right child? So based on this formula, we can do that. 2 times index of this node plus 1 or plus 2. We can find, we can store in the way that it works for the perfect binary tree. And binary search tree, BST, is called a binary tree that is constructed in such a way that it is easy to search for the values it contains. It's because BST it uses some rules. Less value are stored on the left side, and greater value are stored on the right side. So if you look at this picture, okay, on the left subtree here, they are considered on the lesser value. For example, we have a value here. All of those values that are on the left must be less than the root value here. While the right subtree here, it contains values that are greater than the root. Okay, they are the rule that we use to apply in binary search tree, and because of this rule, we can search our data very fast. Every time we access to our data, we divide into whether we go left or we go right. By using recursive, we can find our data very fast. So for example, suppose we have number 15 as the root. This is the root of the tree. If we want to insert our data, let's say 10, so in which way that we should insert our data into? So we check on the root here. Okay, because of number 10 is less than 15, right? So our rule is those numbers that are lesser than the root, we go left. Okay, so our data here put on the left. Okay. And next we want to insert 20. Okay, it's 20. So 20, in which way that it will goes? So it will goes right, because 20 is more than 15, right? So it becomes here on the right, and so on and so forth. Our data can insert in this way, okay, based on the rule. So when we took in the implementation, it's very simple. We just check a condition, right? Compared with root, and then we recursive either to left or to right. Reaching that we can insert our data. So to insert a node in a binary search tree, we have a rule, right? We check whether this value is less than the current node, then we go to the left subtree. This new data should be inserted to the left subtree, and we keep doing the same process, checking with another number until we reach a node, because we will insert a number into that nodes in the leaf. Okay. In the case that the number is greater than the current node, which is started from the root, we will go right on the subtree. So with this simple rule, our algorithm will reach a node leaf which has no left and right subtree. Okay. For example, we have this tree. We have number inside, and then when we want to insert another number, let's say this one, we have 5 here, and we have number 2, and we have number 10. So if we want to insert the number 7, okay, number 7. So where will we insert into, right? We try to reach the leaf, okay, the leaf. So in here, 7 is greater than 5, so we go right? So we go right, okay. And next we check 7 and 10, because this is comparing. 7 is less than 10, so it means that 7 should be inserted to the left of this node 10. Okay, so our new data will be inserted into the left side here. This is 7, right? Okay, So before this left side is actually nil, right? This is the leaf, and it left side actually before nil. Now we new element, we create new element in here. Okay, this is how it works. So given a tree below on the left, how we can add node of number 4 to this tree? So through this we can check, right? 4 is less than 5, so it means that we should go to left, right? So here, because we check that start from the root, number 4 but we want to insert it less than 5, so we focus on the left here, right? So in this picture, as you can see, now we are trying to compare another number, whether our number that we want to insert is 4, we compare to number 2 now. 4 is more than 2, so that means that we should go to the right here. So we go to the right here in the next process. We check more number. Okay, so we can see that 4 is still more than 3. Okay, as we check on this subtree, 4 is more than 3. It means that we can insert number 4 to the right of 3 here, right? So because on the right here, before it has no data, right? It's nil. So now we can insert number 4 in here. Okay. And this is the final our data when we insert number 4 to this tree. Okay. So considering on the way we can insert it, we can create a new function. Say insert here, insert function. We pass the root, what is the root of the tree, and our new data that we want to insert into. We just apply the checking condition base. So we try to recursive here, okay, recursive and recursive here, depending on the value when we are trying to check. Okay, if our data that we want to insert is less than the root, okay, the root, our root data, because we create an element and then we access to our data inside the root. So if the data is less than this one, we go left. Okay, as you can see here, the parameter it pass, we pass root left. It means the left subtree. Okay? So it keep recursive here again and again until sometime that it will reach the leaf node in which the value, the pointer is nil, right? So we're trying to check. So when we recursive call this function again and again, sometime we will reach the nil, right? So the data that we pass here, we keep passing another subtree, okay, root of another subtree, and sometimes we will reach null, right? So it means that we will insert our data here. We just new our data when we point pointer and we insert the data, right? It's just the way we insert our data. Very simple. We will go through that one more time. This is just give you an overview of the function that we're going to implement. And next we will see on how we access to our data inside the binary tree. So traversal here is a way that we use to visit each node in the tree. When we visit, we can access to information, we can display, we can pick up the number or our data and use it in our calculation. So there are two types. The first one we call a breadth first search, and the second one we call depth first search. They are divided into three: pre-order, in-order, and post-order. So in the breadth first search, it means level by level. Okay. So focusing on this simple tree. Okay. So the way we access is that we visit the root first, and then we go down deep inside here, right? And then we start back here. Okay. So which one we pass? So we will get this number, right? Okay. So the data that we get is F. We go from top to bottom, and we visit from left to right. Okay. So we got F, D, J here, B, E, G, K, and then from left A, C, I, and H. Okay. This is what we get if we use the breadth first search from top to bottom and left to right. Okay. And next we will see on how we can use the deep first search traversal.